This is Miss Cotran and
Mr. Hampton.
And we'll be instructing you today.
Are we doing it again?
No, we're doing it now.
Oh.
Lesson 2-3, solving multi-step equations.
In today's lesson, students will learn how to do multi-step word equations.
And problems.
All right, here we go. So, what we're going to do is consecutive integers. We'll be working with consecutive integers. We have a type. Consecutive integers means this. Integers that come in
Counting
order. So this would be numbers like 1, 2, 3, or maybe something like 7, 8, 9, which we all remember 7, 8, 9 because that's why 6 was afraid of 7. Now, the symbols we'll use for these are n and n plus 1 and n plus 2. You might be like, what is n? N is any number you choose. You choose negative 20. Suppose you chose negative 20. What would negative 20 plus 1 be?
Negative 19, Mr. Hampton.
Very nice. Negative 19. And plus 2?
Negative 18.
And so they'd be consecutive integers still. So we can use these type of ideas. And it doesn't matter. I chose negative 20. You could choose negative 1,016. You could choose 12. It doesn't matter. Anyways, so examples are stuff like that. Then we'll move on to consecutive even integers. Even integers are and blank.
Even?
Yes, an even integer followed by an
Even?
integer again. And it has to be consecutive even integers. So this would be, again, you pick an even integer. Can you pick a number like 5? No, because 5 isn't even. But let's suppose we picked an even number, say 12. 12? Well, 12 plus 2 would be?
14.
14. And 14 plus 4 would be? And 12 plus 4, so 12 plus 4 would be?
16.
16. And so we could use any of this type of thinking, really, when we're entering an n. And again, it would work with negatives as well. If we entered a negative 8, then it would be negative 8, negative 6, and negative 4. Something like that.
Yeah.
So we could see it's these type of numbers. Negative 2, 0, 2, 4, continue on. 6, 8, 10, 12. Consecutive odds are odd integers, as you might imagine, followed by the next
Odd
integer. And this works the same way. Pick an odd integer. Oh, I choose 113. Oh, well, then the next consecutive odd integer would be 114. No, it's not odd. 113 plus 2 is?
100 and, you mean 113 plus 2 is 115. Yeah.
115, yes. And the next one would be 117. And so we see here, example negative 1, 1, 3, 5. Again, you're skipping over 0, 2, 4, 6, because those are not odd. Now, we need to find 3 consecutive odd integers with a sum of 75. Oh man, 3 consecutive odd integers with a sum of 75. Well, what would an odd integer be? It'd be something like, well, could it, maybe you sit there and think, well, it could be like 11. 11 plus, what's the next odd integer? 13 plus 15. You could try that out. And you go, oh, well, that's, well, I don't like this type of math. I'll do it this way. 13, that's 24, plus 15, 9, 39. Oh, that's not nearly enough. Oh, 11, 13, 15 is not enough. I need other odd integers. Well, it'd be helpful if we just had a general formula so we didn't have to guess a whole bunch of times. So rather than just kind of guess arbitrary odd integers, what if we actually just had, some sort of consistency here and had an equation? Well, this is where you would go and you'd use one of these equations. And which one are we going to use? Consecutive integers, consecutive even integers, consecutive odd integers. And the odd is in red because the odd is in red. It should match here. So we're going to use odd integers. These odd integers then are going to be what? N, and n plus 2, and n plus 4. And I'm going to add all these things up. And how do you think of these little dots in and of themselves? And they have to add up to what? Sum 75. So now you need to add all these things together. How would you set that up? You go n and n and n and 2 and 4. And, oh, well, luckily the commutative property of addition says I can kind of add these however I want. So this is going to end up being n plus n plus n. That's 3n plus 2 plus 4 plus 6 is equal to 75. We've now come up with a simple algebra equation. And you guys know how to solve this. You do. You can totally solve this. Subtract 6. We'll end up dividing by 3. That'll be your answer. Let's check to see if it works. 3n equals 69. 3n equals 69, divide by 3, and I get, n equals 23. this n equals 23. Let's see if it would work. If n is 23, then this would be 23.
Oh.
Slide this over.
Yep.
This would be 23. And then n plus 2 would be, n plus 2 would be 25. And n plus 4, 23, 24, 25, 26, 27. 27. And use those fingers. Does that add up to 75? Lo and behold, it does. We're good. So that is how you would solve a problem like this. And you would work for anything. If I'd said, well, what if you picked something larger? What if you picked, something like a 93? The sum is 93. Well, you do the same thing. You would just have n plus 2 plus n plus 4 equals 93. And it would come out to work the same way. It would just be 27, 29, 31 instead. So that's how you find using odds. Next one, find 3 consecutive integers with a sum of negative 36. 3 consecutive integers with a sum of negative 36. Okay, so this is just consecutive integers. So in this case, I'm not using this n plus 2, n plus 4. I'm just using, I'll bring it back a little bit. I'm just using n plus 1, n plus 2. So I'm just going to use n plus 1 plus n plus 2. n plus 1, and n plus 2. And what do they have to add up to? A sum of
Negative 36.
I think you can see this is going to work out very similarly. When we solve it, we'll have n, that'll be 3n. 1 and 2 makes 3. So 3n plus 3, you're going to solve it the same way. Ultimately, what are we doing? We're trying to get n by itself, same as all these other equations we were doing for the last couple of days. We subtract 3. And then we divide by 3. And then equals negative 13. I always like to go back and check my work, see if it makes sense. So if n is negative 13, that's negative 13. Negative 13 plus 1 would be negative 12. Negative 13 plus 2 would be negative 11. Gosh, I know you don't love adding negatives. I know that's true. Oh, well, maybe if you notice they're all negatives, then 13 plus 12 plus 11. 6... 3, yeah, that is 36. Oh, but it's negative, 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 so the whole sign is negative. All right, that's pretty much it. Well, welcome back. We're going to go ahead and do a word problem now. Among the career home run leaders for MLB, Major League Baseball, although I dated a girl with these initials, Hank Aaron has 175 fewer than twice the number that Dave Winfield has. Hank Aaron hit 755 home runs. Write an equation for this and find Dave Winfield's total. Man. All right, we need to set this up somehow. We need to have these two things relating to each other. So let's think through what's important here. Talking home runs, we're talking this guy and this guy. And let's use some initials for them. Let's go ahead and say Aaron. We're going to abbreviate Aaron with an A. We'll go ahead and say A equals Aaron's totals. And then we will say that W equals Winfield's totals. And that's in home runs. So there has to be some sort of correlation between the 755 that Hank Aaron hit and these other numbers. And let's take a look at all the numbers. You might be saying, oh, I see some numbers in this problem. Numbers are usually important in math problems. Hank Aaron hit 755. That's important. Okay. 175, I see that one too. Any other numbers, or are we done? I think there might be one more number. It's written as a word twice. That's a number. You got to think of that as like 2 times. So Aaron is somehow related to Winfield. And which one's larger? Well, Hank Aaron has 175 fewer than twice the number that Dave Winfield has. So Aaron's totals do equal 755. Winfield's totals, what is his equal? Well, what would you have to do with Winfield's totals? So I think, well, how do I use this 2 times thing involved? I have to use 175, and it's fewer, so it's going to be minus 175.
Use this marker.
And then it has to be related to 755. So 2 times 175. 755, and I have to figure out how to make an equation out of this. So the truth is, if you can figure out that, if you recognize that Winfield is less, then you start thinking, well, would I go? It's got to be one of these two. It's got to be like 2 times Winfield minus 175 equals 755. Or it's got to be 2 times Aaron minus 175 equals 755. It's got to be 2 times one of them. And which one makes sense? Well, who are we trying to find? Are we trying to find Aaron or are we trying to find Winfield? We're trying to find Winfield because we already know Aaron's total is 755. So now that we have Winfield by himself, we're going to go with this equation. This one's no good for us. Okay, that's not what we want. Let's see if this makes sense again. Just check to make sure the equation makes sense. Hank Aaron has 755 home runs. Has 175 fewer than twice the number that Dave Winfield has. Twice the number that Dave Winfield has. This is a whole statement. Twice the number that Dave Winfield has. That's 2W. 175 fewer than twice that. So this is our equation. 2W minus 175 equals 755. From here, I expect to be able to get it. It's being able to read the equation and come up with a solid answer. Solid equation is the difficult part. The answer I don't really feel is the challenge. I really think you'll be fine. It's coming up with the equation here we'll struggle. 0, carry the 1, unless you can't carry. And that's a 3. And that's a 1, that's a 9. 930 divided by 2, so that's what? 465. Good old Dave Winfield, Minnesota Twins.
Okay, the last 3 examples we're going to look at are some multi-step equations, and we saw these yesterday, so this should be review. I want to start with this equation because the answer is on the left side, okay, of the equation. So it says 8 equals 16 more than 8 times a number. All right, so what do you think you do first? What are you looking for? You're looking for the number, right? But now there's an 8 next to it. So you want to circle this term and make a T to separate both sides of the equation, all right? What do you have to do next? Because there's no sign in front of 16, even though you know you're adding 16. So what do you want to do? You want to do the opposite of positive 16, which is?
Subtract.
Subtract, good job. You're going to subtract 16 from both sides. All right, so 16 minus 16 is 0. Bring down 8n, and 8n will be 8 minus 16. So these are different signs. Different signs subtract. Keep the sign of the bigger number. You should get negative 8. So if negative 8 equals 8n, how do you find n? Remember, 8 is being multiplied by n. So what is the opposite of multiplication?
Division!
Good job. It is division. So you're going to divide both sides by 8. And here you have a negative 8 and a positive 8. Remember, Bob, you have a negative divided by a positive equals negative. So 8 divided by 8 is 1, but because you have this negative, then negative 1 equals n. If you were to check this, if you have 8 times negative 1, that would be negative 8 plus 16 is really 16 minus 8 does equal 8. Okay? Let's look at number 6. Number 6 says a number divided by 3, if you add 4 to it, gives you negative 16. All right? So if it helps you, you can, again, circle where you see the variable, okay, and it's being divided by 3. You could separate both sides of the equation. So what do you have to do to get k divided by 3 by itself? What do you have to do? You have to do the opposite of positive 4. What's the opposite of positive 4?
Minus 4.
There you go. You're going to subtract 4 from both sides. Very good. All right, when you do that, you're going to bring down k divided by 3 equals negative 16 and negative 4. Remember, these have the same signs, so it's same signs, add and keep, just add negatives. 16 plus 14 is negative 20. Okay? Now, there's a few ways you can do this. I saw a lot of students yesterday saying, okay, well, if k divided by 3 is negative 20, I should just multiply 3 times negative 20, and that would give me k. And that's true. But really, since k is being divided by 3, what is the opposite of division by 3? It is?
Multiplication by 3?
It is multiplication by 3. Thank you very much. Whoa. So you multiply both sides by 3, or the reciprocal of 1/3 is 3 over 1. When you do that, the 3's cross cancel, and you get that k equals negative 20 times 30. What's the answer? Don't tell me. What is it? It's negative 60. Good job. Okay. Good. All right, and quickly we'll take a look at number 7. Again, I like to choose these because the answer is on the left side. It says 14 equals 6 plus z. This is a z. I just made it like this so it doesn't look like something else. Divided by 2. Okay, so the first thing you need to realize is that this, and if this was in parentheses, that's fine too. Z, first is being added to 6, and then it's being divided by 2. So you want to really get rid of the denominator. How do you get rid of the denominator? Remember, what's the opposite of dividing? It's multiplying. Good job. So you multiply both sides by -2. When you do that, the 2's cross cancel. You are left with 6 plus z now equals -2 times 14, which is negative, what is it?
-28.
There you go, it's -28. All right? All right, so that was your first step of this equation. The second step then is to isolate z. Get z by itself. You want to find it. And then you want to do the opposite of +6, which is -6. And bring down z. +6 and -6 make 0. And again, you have -28 and -6. So this is like the third time that we've seen when you have two negatives together. Now, when you have two negatives together, let me make sure you understand this. This does not mean negative plus negative is positive. No. When you're adding integers, really, these are two negatives that you're adding together. Okay, so that's why you say same signs add and keep. So the answer will be negative. What is the answer? When you add them together, you get 34, -34. All right, so make sure you get that down, and we will do some practice problems.